For example 3, it just wants us to state the independent variable and state the dependent variable. So here, my independent variable is the one that's on the right side of the equation. It's going to be r. My dependent variable is going to be the one that's isolated. It's going to be c. For example b, the independent variable is going to be my horizontal axis, so t, and my dependent variable is my vertical, so that's going to be h. For c, when it's written in words, the amount of sap S obtained from a tree is dependent on, and here's the key terms, dependent on, which means that this is my dependent, the time t a container is left attached to the tree, and there's my independent. Independent is t, dependent is s. If I'm investigating relationships by plotting ordered pairs, in this section we'll consider the relations defined by an equation and sketch a graph by plotting the ordered pairs. So we're going to make a table of inputs by choosing replacements for the independent variable, and for each of the independent variables calculate the corresponding output and then plot the data. So it says, consider the relation described by the equation y is equal to 2x minus 5. The first thing it wants us to do is it has given us 5 inputs. It wants us to solve what the outputs would be. So if I'm trying to find what the output would be for -2, then in my calculator, if y is equal to 2x minus 5, I'm going to say that's going to be 2, put a bracket where x is, to make sure that I replace the variable properly. Make sure you're using the negative button and not the minus button in there as well. Minus 5. And in this case, I'm going to wind up getting -9. If I did the same thing for the next one, then I would have 2 times -1 minus 5, and I'm going to get -7. I can keep doing this throughout all of them, and when I have 0, it's going to be -5. When I have 1, it's going to be -3. When I have 2, it's going to be -1. I'm going to plot the ordered pairs from section A on the grid. So I'm going to start at the point of -2 for x and -9 for y. And there's my first value. Then I'm going to go to -1 for x and -7 for y. I'm going to go to 0 for x and -5 for y, 1 for x and -3 for y, 2 for x and -1 for y. I'm going to connect these points, and if I'm being careful about it or using a ruler, when I extend them, it should connect out like this. And I'm going to include arrows to say that it could keep going up and to the right, it could keep going down to the left. If I'm using the graph to determine the value of y when x is equal to 6, well, if I connected them properly, then I'm going to go to when x is equal to 6. I'm going to go straight up from there to see where it connects. And I reach this point, which is 6 and 7. if I'm using the equation to determine if this is true, or if I graphed it properly, I'm going to say that y is equal to 2 times my x value, which was 6, and minus 5. 2 times 6 is 12, minus 5 is in fact 7. And this one does work. If I'm writing the value of y when x is equal to 6 on the table of values, then I'm going to go up here and say that when x is 6, y is 7, and I have coordinate of 6 and 7. If I'm using the graph to determine the value of x when y is equal to 3, then in this case, I'm actually starting out with the y, where I'm going to say that from the origin I'm going to go up 3 for y, and then head straight to the right in this case to connect with the graph. And this occurs at the coordinates of 4 and 3, which means that x would equal 4, and I'm going to put this information in the last row when x is equal to 4, y is equal to 3, or I have the point of 4 and 3. If I'm completing the statement below, then what I'm going to say is that this relation is called a blank relation because the relation is in a straight line. If it's a straight line, we call it a linear relation. A linear relation means that the equation or the relation that I'm representing, if I represent on a graph, is going to create this perfectly straight line. It doesn't need to be continuous, but all the points would have to be able to exist along a straight line. All right, in this case, we're just adding an x squared, but we can still do the exact same process that we did in the previous case. If I'm completing the table of values, starting with 4, then I'd say that y is equal to bracket 4 squared minus 6, and that's going to give me 10. And then all I'm doing is I'm just continuing this pattern. I'm going to replace the x with 3, and then 3 squared minus 6, and I'm going to get 3. So I have the point of 3 and 3. If I keep going, then when I replace x with 2, I get negative 2. If I replace x with 1, I get negative 5. Replace it with 0, and I get negative 6. Positive 1, and here's where I'm going to have to be careful when I'm subbing in the negatives. Make sure to get the proper answer, you're using brackets, is actually negative 5. If you didn't use the brackets, then it's going to give you a different answer. Negative 2 gives me negative 2. Negative 3 gives me negative 3. And when I'm plotting these ordered pairs, I'm going to start at the point of the input of 4 and 10. Right here. And then I have 3 and 3. Then I have 2 and negative 2. 1 and negative 5. 0 and negative 6. Negative 1, negative 5. Negative 2, negative 2. Negative 3 and 3. Sorry. I should have been positive 3, not negative 3. And I can connect all these points as best as I can. and I know it's going to continue onwards. Because if I'm looking at it properly, I can see that if I drew a vertical line right through the lowest point, then you can see that these are symmetrical. Then that means that if I went to -4, it should be the same as +4, because -1 was the same as +1, -2 is the same as +2. So if that's true, then -4 should also be 10. And it's going to continue on this side as well. I can prove that if I use my equation and say that y is equal to -4 squared minus 6, and -4 squared is the same as +4 squared. It's just 16 minus 6, which is going to equal 10. I already connected the points of the smoothed curve, and why is this called nonlinear? It does not make a straight line. Simply put. All right, go ahead, get some practice.